There. Terry. All right, first thing I want to say before I get started today is I'm going to be running late this Wednesday. I'll have Jeff open up the lab so you can start working on your lab. But I'll be here, but it's probably going to be closer to 11:30 before I get here, and I'll lecture then, okay? So that'll be Wednesday. Everybody clear on that? Just be careful not to hurt yourself. All right, I want to talk a little bit. We've been focusing on the sequence of operation. I want to, this is still the units that were bugged from last week, same bugs. I know some of you might have already gone through all 10, but we started a little basic. We're going to get more difficult, more advanced. But I just kind of want to walk through electrically schematic diagram and just a regular wiring diagram to make sure we're testing at the right location, okay, for everything to work right, okay? So, that said, let's see, we can write this over here. Okay. So, we go to our units and we have a disconnect, right? And we have what we call an L1 and an L2 and a T1 and a T2. Now, on some of the units, we have a second disconnect, right, on the other side there. It may be a breaker, but it's still a disconnect. And so, both the condenser unit and the air handler have their own power source. But some of these over here only have one power source, right? So for this stuff to work, we're going to have power at L1 and L2 and L1 and L2, or if we just have one together. Does everybody follow that logic? All right, and so schematically, we're reading across a source of power here, right? In this case, we're going to have what, 210 approximately. Okay? The next thing we have to have is these disconnects have to be working correctly. In other words, I haven't been in there and put in some paper or some plastic where the power doesn't get through, right? And so we're going to need power at T1, T2, T1, T2, have some kind of disconnect there, right? And it will be closed. And so here again, I'm reading across the source here, right? Whether there's one or two disconnects. In real life, unless it's a package unit, we're going to have one outside and one inside and one outside, right? Because you can't be that too far apart, logistically. All right. Now we're going to talk about T1 and T2 are going to feed in here. And since we do not have strip heat on most of these units, a heater kit. When you have a heater kit over 5 kW, that's a certain amount of amperage, and the manufacturer is going to have to give us some kind of fuse or breaker control for that heater. So if we don't have heaters, we really don't have that. But if you, like unit number 2 does have a heater kit, and it's going to have a breaker in here that you have to retest, right? But more than likely, what we're going to have here is some kind of wire nut, right? Y'all follow me? There's no really good place. There's a couple of them that do have a terminal block. But this is not an easy place to test. If you're testing, have y'all all tested a wire nut? You got to get the wire nut turned up, you got to get your lead, you got to get it stuck up in there. And you only got two hands, and then you got to do it to another one. So it's kind of difficult. I've seen some people take out the wire nut with an alligator clip. That's fine, except for if it's hot. When you take it off, you might touch it, or it might touch the shell, the frame, or something. So that's dangerous. You can do it. It might be best to cut it off, take the wire nut off, put your alligator clips on it, then cut it back on. But at some point, we're going to have power to the air handler. I don't know how you're going to test that. It may go feed straight into the transformer. Okay? What side of the transformer is what we talking about here? Primary. To the primary side of the transformer. Or it may have wire nuts that it's going to the fan motor, it's going to the transformer, and so it doesn't go directly there. And these may all be insulated. Now, some of these transformers have terminals where you put a stake on. That's a little easier to test. So over here, we're saying, hey, I've got to have power to my transformer. And that's going to be 210, right? Although it's kind of hard sometimes to test it. You may have to cut the power off, take off a wire nut or something, maybe take a stake on and move it a little farther back so it's not covering all the mail. Whatever you need to do so we can get an accurate voltage test of the transformer. If it doesn't have voltage, there's no reason for it to produce secondary voltage. Okay? After we assume that we do have a proper check here, then I want 24 volts check coming off the secondary. Here again, maybe we got two yellow wires that are running out the second. Maybe I've got a yellow and a blue or something. Or I don't know what colors. Or maybe there's some male stake-ons that are easy to test. Sometimes it's easier to test than not. You have to run those wires down, find out where they end, and test it. Most of our units are going to do what here? The hot side is going to go do what? It's going to go through a fuse. Right? A little 24-volt blade fuse in most cases. Some cases might not be a fuse there. Can I test voltage at a fuse? Well, I can, but I don't know what it means, right? Across a source or across a load. A fuse is not a load. So, more than likely, what you're going to have to do is when you tested this, okay, I got 24. You're going to have to hopscotch to the far side of the fuse and say, do I still have it? Okay? So let's say you tested that far. You've got 24 volts coming out of the 24 volt fuse. Where does that power go now? Thermostat. So we're looking for a wire to shoot out to go to our R terminal. You may or you may not have a common out here. Have you heard me discuss that? Could be any color. We don't know what wire thermostat they had on their truck when they installed it. But this is the rule. On most people's homes, they don't have a 24 volt common out there. The only need for a 24 volt common out there is if I'm going to run something, operate it. What am I trying to run on a thermostat? Used to nothing. Now, some of the new digital with a light, they either put a battery in there or you have to run a common out there for it to run. Some of you have looked at it and go, well, I know I got 24 because thermostat's on. And then it turns out you look at it, it's got a battery. So that's not necessarily the case. Okay?
Mine set up like kind of like that, like my batteries go dead.
It'll say low battery. So yours doesn't have a common. Yours is running off the battery. That's fine. Most thermostats don't need a common. What are they doing? All we're doing is diverting the power to, that's supposed to be a G, y'all, I'm sorry. Right? Connected power. That's a switch. That's not a load, is it? If I switch power, G, Y, both of them, W, O, whatever, I'm just switching power. I'm not consuming power. If I consume power, I got to have a common. All we're doing is switching, right? We're only dealing with the path here. Okay? So, yes, sir.
Is something as small as a little bitty light in a thermostat? I mean, I know it's consuming power, but is it even enough to register consuming power?
Yeah, it is. Now, some of the old train WeatherTech ones, they had a little light there that would say auxiliary power, emergency heat power, maybe a blue light for trouble or something like that. Those were hard to pick up on consuming, but yeah, that's enough to consume power. And that LED, I'm sure it's only drawing tiny amount of amperage, but it's consuming power. So what we're telling you here is it may or it may not be easy to test my voltage at the transformer, right? Not to mention, y'all, I mean, up here we got a lot of digitals, but on a regular non-digital thermostat, mercury or bimetal, sometimes there's 3 layers, what we call a base, a sub-base, and a cover. You take that cover off, you can see the mercury switches. The actual connections are behind it. Once you take that off, well, the mercury switches make the connection. Now you've got an open switch. And we said you running checking voltage on an open switch or a closed switch, which we know this one's open, probably going to read voltage. But we can't guarantee it. So reading the voltage out here, unless you take the cover off, and it's a digital, and it says R and C, and the C has a wire connected to it, then we can check it, right? But chances are, we may have to check it like this. R back to common wherever it is. All right? So, when we call for cooling, we connect to yellow and G. Yellow and G. So G is going to come back inside to the coil of my BMR, blower motor relay. And it's going to have a 24 volt common connected to the other side of the coil. And so with the thermostat calling for cooling, I can easily check right here. Boom. Of course, if I hear the blower motor running, I can probably safely assume that I've got voltage there, right? Unless what? It's a ring. Because a ring has a board. And that board automatically energizes the blower motor relay to run whenever there's a 24 volt problem. Okay? What is this BMR going to do, whether it's on a board or not? We'll have the leg off. Run capacitor, right? It's going to be an open switch here to run the blower motor. That's what we want, right? When you call for cooling, the G is energized. It energizes my BMR relay, which closes my contacts, and the blower motor is running. Now, at the same time, my yellow is going to come out here and connect to what? My contactor coil, right? It may be a 2-pole or a 1-pole, I don't know. And this contactor coil is going to have, we're going to have at least 2 wires to the outside unit, 24 volts, to that common. And so if I'm calling for cooling, and you check the disconnect, and you check the transformer, right? And you go to the condensing unit, I should have 24 there, right? Why would that thing work if I don't have 24 there?
Stuck.
Maybe stuck, yeah. And that simply is going to be what? Probably a frozen coil, right? The condenser's always running, and the inside thermostat says, hey, we're cool enough, it cuts off the blower motor, but the condenser's stuck on. So it keeps producing cold air inside. That's probably going to freeze up. So here we're breaking this power here. So let me get back to my schematic. We're going to power R at my thermostat. My thermostat's going to connect to both the G and the Y when it's calling, right? If it's in the off position, it's not. Here we're going to energize BMR coil and the contactor coil. Very similar parallel circuits. All we're trying to do is give you some guidance. If you get lost and go, I don't know what's going on. Where to check my voltages, right? Now, this is going to supply power to what, y'all? A compressor and a fan motor, right? And we're going to have what to both of those? A capacitor, right? Now sometimes we have what we call the split run capacitor. Some people call it a dual run capacitor, and all it is 2 capacitors packaged in one package. But we still need it, whether they're separate or dual, and they have to be working. They can't be blown open. They're going to be labeled as C for common to both. That's the incoming power. We're going to usually have an H for hermetic to the compressor start, an F for the fan start, and they always connect to the start. Now, if I've got a bad component, I might expect to see the condenser fan running and the compressor not, or the compressor running and the condenser fan not running, right? They can go out at the same time, but it's probably unlikely. If they're both not running, my first suspect is the contactor, right? It controls both of them. You go, hey Clay, I checked the coil, I got 24 volts. I checked the incoming power, the L1 and L2, the contactor, and I had 210. I checked the outgoing, the load side, the T1, T2, had 210. So I can say, well, I got proper voltage, the contactor's working. The only other thing that connects them both is this, if you have a dual run capacitor. So you know that's dual capacitor. So here's my fan. Here's my hermetic compressor one. Let's say this is a 30 UF. This is a 5 UF. So we simply run power into it. And where does this go, I said?
Start.
Always to start, thank you. And where does this go? Always to start, right? So this goes to start on the condenser fan. And I should say this is a run capacitor. Run capacitor. And this is going to go to start on the compressor. Now,
what happens if you do connect it to the what's the other, the run? What happens if you do put it on the run by accident? Will it screw it up?
no, but it may not start. More likely, this won't start, and this might.
Oh.
What we're doing is we're not getting capacitance to the start winding. The start winding, if we still got voltage to the start winding, it may be out of phase enough to still run. More unlikely on the compressor. Because we're starting to pump against pressure, where here we're simply trying to decide what direction to go. Okay, so, but with a dual, we're going to put these both together in one can, and we're going to call this middle one the common, right? And over here I'd call it the fan, and over here I'd call it hermetic, right? But bear in mind, inside of here, there's a fuse. You know, a little fuse. And if it blows, no power. That means no power to my starts. And so if you sit there both not running, that could have caused it. I got no power to my start terminals. So either my contactor or my capacitor could keep both of them from running. Now, there is a third possibility, I should say. Let's say there's something wrong with the fan motor. It's starting to get old, it gets hot, it cuts off. The overload is pulling too many amps, cuts off. Well, when the fan motor cuts off, the compressor's going to keep running. The compressor runs till it gets hot, and then it overloads. So now you're looking at them, both of them aren't running. The difference is they would both be very hot. Okay? On the good old ring, you know, they've got an outside, they almost always have an outside resettable pressure switch. In other words, when the pressure goes down, it doesn't reset. So that situation happens. You get there, condenser fan motor's done cooled off, and it reset, and it's running, but no compressor. So down there on those, they always give you a little button down there where the refrigerant lines come in there, and you push that button, and you reset the pressure switch, if that's what it is, and it's going to crank right up. You know? And if a customer sees that, good Lord, because they're going to go, oh, I knew it, y'all trying to cheat, y'all got a button out here, y'all making me pay. And so from then on, they're going to push that button before they call you. That doesn't
Make sure
necessarily
they're
fix
gone.
what happened to begin with, but that will get it running.
Make sure they're not around when you mash that button.
Yeah, you might want to be real overt about it. Like, okay, just say a little magic. Okay. All right, so we're going to continue our electrical troubleshooting. Everybody got my message on Wednesday, right? Come on in. I'll have Jeff open the lab so you can finish your labs or work on your computer, those labs. And I'll be in here to lecture. We will probably finish the handout on electrical. There's just a few more things to talk about, really, in electrical. And does anybody have any questions? Is anybody having a difficult time on a certain part of it? Like usually it comes from you understand it here, but you don't see where to actually take voltage readings out there. You're going, I don't see where to take it. And that's the logistical hard part is when you get to a thermostat, you go, I think the problem's in here, but I don't know where to test. That kind of thing. And usually, y'all, when a thermostat's in question, especially if it's a digital, man, we're not electronic experts. Just get you your little alligator jumper and jump from red or R terminal to green. What does that do? That says you're making the power go right there. Even if the thermostat's broken, you're sending power to the bottom of the relay. It should come on. You jump it to yellow. That should bring on the condenser, the outside condenser. Although, in a house setting, you may have to go outside and look if you think it's the thermostat.
So you jump it.
You just jump it, yeah, because all a thermostat is a switch.
Oh,
And so when we add a circuit board and some of them are programmable, sometimes it's just best to go ahead and jump across to our terminals. And you can tell the customer, okay, do you happen to have the manual on this programmable thermostat? They go, I know we need to keep that. And you go, okay, it's your thermostat. I'll be glad to sell you a new one. Because it's not our job to memorize all 6,000 thermostats on the market and how they're programmed. That's not us. All right, I'll let y'all go to the lab.